Hello, students. I hope you're doing well this Monday morning, afternoon, depending on what hour you are seeing this. I'm off in California just living my best life, and now you get to live your best life learning about algebra and geometry. As a reminder, here is our schedule for this unit. It's an exciting week for us because, as you can see, this Thursday for you all, we will have our Unit 3 test. Yes, that is this week. That is Thursday. It will happen. What that means is that today we're going to finish up our last set of notes. Once again, today we are doing our last set of notes, 3.5 Symmetry. What is this? PDF highlighter? Don't need it. Then next class on Tuesday, you will be given a review to work on. As a reminder, I won't be there Tuesday either. So be nice to the sub, work quietly and respectfully, and do your best to understand what's happening here. We will have time a little bit at the beginning of Thursday to go over a couple things, but we will not take a long time, so it is important that you are using your time wisely in class. Well, 3.5, it's over symmetry. Some of you have probably heard that before. I'm just scrolling down to that lesson. Here we go, we're getting closer. And 3.5. Some of you have probably heard of symmetry before. Typically, if you have, it's in an art class or like another place that we see symmetry is like Valentine's Day cards, where you fold a piece of paper in half, you cut out half a heart, and then it makes the whole thing. What is symmetry? When we talk about symmetry, we are talking about moving a figure so that it looks the same. This isn't a perfect definition, but as we work through, we'll fill in those gaps and see more what I'm talking about. There are two types of symmetry that we're talking about in this class today. The first being line symmetry, the second being rotational symmetry. Line symmetry is when you have symmetry that's made from reflections. So when you reflect something, when you reflect something over that line of reflection, that's what gives us line symmetry. Rotational symmetry, as you might imagine from the name, is symmetry made from rotations. And we will look at both of these here to see what is happening. Well, we're going to start with line symmetry. To look at line symmetry, we have some of these like word boxes. And so the question here is going to be determine what kind of line symmetry we have. Our options, we're going to either say we have horizontal symmetry, vertical symmetry, or diagonal symmetry. Diagonal. I always have to figure out how to spell that word. So what that means, when we look at this first word, hook, is there any way we can cut it and fold it so that it matches? The answer is yes. Imagine with me if I cut right across the center and then I fold it over. So let me try this. See what happens on that top side? See how I'm highlighting what we see on that top side? If I mirrored that or reflected it down, do you see how it would create that word hook? So because we can cut it and it would still look the same, or really fold it on top and we'd get the same thing, it does have horizontal symmetry. Just to show you, if we didn't have horizontal, or if we had vertical symmetry, well, what would happen? Well, this O, well, that would be symmetrical, right? If I fold it, those O's would line up. But if I fold this H over, well, what's going to happen is that H is going to show up on top of that K, and we wouldn't have matching pictures. So we don't have vertical symmetry. When we look at this vertical line, that does not create symmetry. So here we just have horizontal. We could try diagonal, but it's not going to work. Well, this next word box is mom. If we want to try horizontal symmetry, you could see, let's use this red. So we kind of have this kind of tracing. Well, if I mirror that tracing, we do not get the word mom. Let me drag it. That is not the word mom, right? If we have symmetry, actually, let me show you. Let me go back to hook to show you that again. When we have symmetry, so I trace what's on the top of it, I mirror it, if I bring this down, do you see how we still have that word hook? It still looks like the word hook. So that means that horizontal symmetry works. Here we have some weird jumbled up mess for mom. So it's definitely not horizontal symmetry. The question is, what is it? Maybe we'll try vertical symmetry. Well, if I trace and trace, when I fold it, I'd end up getting this. Maybe we can see that when I drag that down, you can see we still have that word mom, right? So here we do have, we can draw that line, we do have vertical symmetry. We don't have horizontal, and we won't have diagonal. What about bib? Think about this one. Horizontal, vertical, diagonal. What do we have? Pause or just keep listening to me ramble. I'll give you like 5 seconds. 5, 4, 3, 2, 1. Okay, I'm done. This would have, ooh, bad line. This would have horizontal symmetry. If we cut across, it would line up and match. So we have horizontal symmetry here. Finally, this last one, this is an interesting case. You might guess horizontal. Well, if I trace, and if I mirror, you can see I don't have that word noon. So it doesn't have horizontal symmetry. It's a weird jumbled mess. If I try vertical symmetry, we would get, now I have to be careful, this. And here you can see something funky happened here with that N. So it doesn't have vertical symmetry. And so here we will say it has none, no symmetry. Okay, so that's what you're doing. You're thinking about how can you cut it? Can you cut it horizontally? Can you cut it vertically or diagonally to create that symmetry? Well, that's the line symmetry. That's all we're doing for line symmetry. The next thing to talk about is rotational symmetry. Well, to do rotational symmetry here today, we need to remember how many degrees there are in a full circle rotation. If I go in a full circle, we say that's 360 degrees, right? 360 no scope. So to do or to figure out how much rotational symmetry we have, we first need to figure out how many times our shape maps itself in a full rotation. We'll look at what that means. And then we do 360 divided by that number. So, looking at example 1 for rotational symmetry, we see this circle with some stars and a plus. What we are doing is, see how if I took this shape here, if I spin it this way, it would look the same, right? Or I could spin it another section, or another section, or another section. Each one of those spins would end up with that same picture. So see how I have 4 spins in a full circle, right? I could spin it 1, 2, 3, or 4 times. So what we do is we take 360 divided by 4. Well, with my itchy nose, with my calculator in hand, 360 divided by 4, we figure out that we have 90-degree rotational symmetry. Well, let's look at number 2. The question is, how many times can we spin this and get the same picture? I can spin it once, twice, 3 times, 4 times, 5 times, or 6 times. 1, 2, 3, 4, 5, 6, which means I take 360 divided by 6. My mental math tells me that would be a 60-degree rotational symmetry. That's all you got to do. Count how many times it works, 360 divide that number. The next one, we have this flower-looking thing. We can go once, twice, thrice, 4, 5, 6, 7, 8. So we have 8 total rotations that will work. So 360 divided by 8. My mental math, you can type this in a calculator, you can do long division. It ends up being 45-degree rotational symmetry. Well, this last one, we can count 1, 2, 3, 4, 5, 6, 7, 8. Also 8. So we're also doing 360 divide 8, which is still 45 degrees. It's a bit laggy, isn't it? Because I'm hands off. Good. That's it. That is line symmetry and rotational symmetry. So you have a practice over this symmetry to be working on. I want you all to be working quietly, respectfully. You can work with each other with your table groups, but you need to be on task. If you finish, you can turn it in, but then just find something else to work on quietly and respectfully. Thank you. I hope you have a wonderful life. Now I have to remember how to